So thank you guys so much for having me out here. What I'm going to do is give you just kind of like a brief little story about kind of how this all came about and what my mission is, and then we're going to end with some fun demos, because why not? And so, like she said, my name is Dr. Kate Biberdorf. I'm a chemistry professor at the University of Texas, and 4 years ago, I was sitting in my office, literally just like a block up here, and I received this email from a colleague, and it was like, Kate, I'm going to be on We Are Austin, which is like our local variety show, comes on right after the morning news, and he's like, I'm going to be promoting this upcoming event. Is it possible for you to come out and do like a little science experiment on this show and like help jazz it up? I was like, sure, yeah, I'll try it. And so I go there, and I was basically his prop monkey. I mean, I was standing there. I wasn't even mic'd up. I was handing him gloves. I was handing him goggles. Like, I did nothing. I didn't say anything. And after the segment was over, this woman comes charging into the studio, and she was like, that was awesome. Do you guys do anything for Halloween? And before I could even process the question, I had my palm in the middle of this colleague's chest. I mean, it's a tenured professor, like the blazer with the tweed, like he had it, right? And I just like shoved him out of the way and charged at this woman. I was like, yes, okay, I can make a genie, I can make a ghost, I can make a pumpkin vomit, explode, smoke, I do all these things. And she was like, shh, 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 crazy lady, shh, shh, stop it, stop talking. And so basically what happened is I was allowed to come back and do my very first segment on We Are Austin. After this segment, she came out and said, do you do anything for Thanksgiving? What about Christmas? What about New Year's? And before I knew it, I was having a monthly segment where I was out on We Are Austin doing a demonstration. And so what I had to do is kind of figure out how to present my science. I am used to talking to these beautiful students here for 75 minutes about one topic, and they have to be there. They're forced to be in that classroom. For this, you are voluntarily choosing to watch this show. And if I don't keep your attention, you're going to change the channel, which means they're not going to invite me back there. And so what I started doing was talking about a real-world application right away. Like, what we're going to do today, you're going to see X. And then I started doing the demonstration, and that's when I had to evoke William James's theory of emotional memory. And so I was raised by psychologists, so I kind of believe... And so, but this is like the one thing I totally agree with them, is that if you have an emotional response to something, you're more likely to make a memory. And so what I do is I try to have a demonstration, and I get as excited as I possibly can about it, to kind of force you to either love me or hate me, one of the two, I don't care, but one of them, and have that emotional response so that after I do this, I can then shove that chemistry knowledge into your brain for about 20 seconds if it's on TV, but in person it's about 60 seconds. So this led to a number of different opportunities, including this awesome one with Amy Poehler Smart Girls. And they actually came out to our lab here at UT Austin, did a number of different demonstrations, and I was talking to them, like talking to the producer and getting real-time feedback on my explanations. And it was either really, really good, she would have a big smile, or she'd look at me like, oh my God, you just started speaking in Klingon in the middle of that. Those were her words, her exact words, like Klingon, okay? So I had to, again, change and fine-tune my language. How do you talk to a 7-year-old and a 70-year-old? Because that's their audience, which was really difficult. But the videos were done really well and edited very well. Thank you for Amy to that. And that caught the attention of NBC Nightly News, and then more recently, CNN Great Big Story. But again, a totally different audience. This is news, right? This is 6 p.m. They don't want me going, yay, science! Like, no, that is not what they want. They want the facts, but that's not me. I have a little bit of bubbly personality. You might have noticed that. I'm a bit of an extrovert. And so for me, I had to figure out how I could keep my authentic self, but still present the facts in a news fashion. Well, that led to Pickler and Ben. If you know Kelly Pickler, that was really cool. It was awesome. She's amazing. Which led to Wendy Williams, which more recently led to Stephen Colbert, where he let me do that. And then I got him to do that, which I thought was pretty cool. I mean, you can actually see my face. I am like beyond excited that he was able to breathe fire. I had to go through 3 of his security guards and 3 fire marshals in order to do that, but they still let me do it, so that counts. So then I did what I promised myself I would never do, and I read the comments, right? You're not supposed to do that. And I'm going to be very clear. There was a lot of hate, but haters going to hate. I don't have time for that noise. We're not focusing on it, okay? So what we're going to do today is just focus on the good things. So here were a couple of them. The first one was how cool. I was like, okay, I still have my self-esteem. We're okay, all right. The next one, science, big bold letters. And then I wish I had a teacher like her when I was growing up. My 7-year-old daughter was mesmerized by this video. She could not take her eyes off the screen. Thank you for showing young girls that women can be scientists too. But then this one, this is the one that just like uppercut right in the gut. I finally found a role model for my 10-year-old self. Can I say it again? I finally found a role model for my 10-year-old self. So this one hit me and really resonated with me because you are looking at the girl who grew up with Bill, right? Bill Nye the Science Guy, you know him? Yes? Okay. So I love him. But how cool would it have been for like one female scientist to be on TV, like a Jill Nye the Science gal, just one, like maybe just a girl, but possibly. And so I decided that I had to do something with this platform. It's not just me on Steven, it's not me on Wendy, like it's cool and I'm super excited about it, but there's more to this. And so I tried to do something that would make my 10-year-old self proud. And so I did what I always do, and I listened to Taylor Swift. And I was like, all right, what would Taylor do? And so I'm assuming, I don't know her obviously, but I'm assuming that she is a strong, confident, powerful, talented woman. She's also beautiful, but notice I named that fifth, okay? That's like her least, everything, just that tangent, next time, okay? So, but she has a squad. She has a squad and she supports her squad. Every interview she does, she talks about her female colleagues. She promotes their music, she shares their stuff, and she is a big, big proponent of their work. And so I decided I'm gonna do the same thing. But I'm not really good with the word squad. I stumble saying that, so I decided I'm going to build a STEM army. And the first person I recruited was Livia Eberlin, and she is my age. She's smarter than me, she's prettier than me, she's better than me in every aspect of the world, but I love this woman. This is why. She figured out how to put a mass spec at the end of a pen so that during surgery, surgeons can figure out in real time if those cells are either cancerous or benign. In real time feedback. It was so cool, it was featured on Grey's Anatomy. STEM Army. Number 2, Emily Kay. She recently just won a Teaching Excellence Award, but her research is even better than that. She figured out how to make fertilized eggs glow. So the second the sperm hits the eggs, boom, glow. STEM Army. Shagufta Shabir, her students call her Shabay. Enough said. Fatima Fakhardin was just nominated for the Texas 10, which means she's one of the top 10 professors in Texas. Well, okay, so technically the University of Texas, but we think we're the best, so I'm just going to say Fatima's one of the best professors in Texas, and so she's part of my STEM army. But this is just a small subset of the female faculty members. I didn't even mention my male colleagues or my colleagues in engineering or stats or anything else like that, or my graduate students. I have graduate students who now are inviting virtual presentations into our lab. So via a webcam, we're having conversations with people in Macedonia, in Michigan, in LA. We're having these conversations through a webcam. It's awesome. We also have an undergrad who is going out to an all-girls middle school here every single month, because research shows that if you show up once and leave, it's not going to make a difference. But if you show up every single month, you can grab these girls right before they hit puberty and hopefully encourage them to follow their dreams in STEM. So what I'm trying to do is build a STEM army. That was the first thing I decided to do with my platform. Number 2, I decided to engage in evidence-based conversations. I no longer can hear someone say, climate change isn't real, and just go, la, 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 la. Like, no, I can't do that anymore. And so my effort or my strategy is I use questions, and I always talk with data. I go, okay, why do you believe that? Have you seen this graph? No, you don't like this one? What about this one? No? How about this one? This one really looks to me, I like climate change is real. And if they still fight with you, take a step back. All right, how is the data collected? Is there something here I'm missing? Is there something wrong? Like, what? Tell me, what don't you like about it? But ask questions. And I need to be very clear. There is no point for condescension here. We cannot be rude. We can't be like, you're an idiot. No, like it doesn't work that way. You have to be nice. You have to say, oh, you don't know what quantum mechanics is? Like, come here, let me tell you about it. It's awesome here. Not like, oh, you don't know quantum mechanics? Ugh. Like, no, we don't do that, okay? So evidence-based conversations. And the last thing, which I think is the most important thing, is you have to talk to kids. You have to talk to kids, as many kids as you can. You need to talk to sick kids. You need to talk to crazy kids. You need to talk to all the kids you possibly can. But unfortunately, I get the same question, like how? How do you engage in that conversation? I'm an extrovert. I love talking to people. I love to talk just in general. You might have noticed that. But my colleagues, not so much. A lot of times they're introverted, and so I get the same question, how? How do I engage in the conversation? Fire. Duh. Okay? Every time. Fire. That's my go-to. Unfortunately, the library has banned fire, so today I'm just going to do other things. I will show you what else you can do if you can't have fire. But let me show you really quickly about 3 things. Here's Jax. Jax is an undergrad that I taught how to breathe fire 3 years ago. Now he's going around all across campus doing LGBTQ allyship training to student orgs. And instead of being like, be a good person, he's like blowing fire, doing experiments, and actually teaching people how to be a good ally through science. Here's Nicole. Nicole I taught how to breathe fire 2 years ago. Now she's a graduate student at Rice University. She has her own outreach program. She develops her own demos, her own lecture series. She's talking to kids all the time. I could not be more proud of this woman. Meet Victor. Now, just for the record, you and I know Victor equally well at this point. He's a stranger, and he emailed me that picture. And he works for Teach for America at an inner city school in Arkansas, and he's been following my career and figuring out what he can do. He doesn't have access to a lot of the resources that I do, so he's been creative. He can find anything at Home Depot, so he says. But then he showed me this picture because he finally mastered the fire-breathing dragon, and he wanted to show me what he's doing in his own classroom in Arkansas to try to promote STEM and trying to get kids excited about science. So I think that's just one of the coolest things. But now here's the thing, y'all. I told you I'm building an army, so I need your help. So I would like to recruit you to be part of my STEM army. So if you hear incorrect sentences about science, ask questions, use evidence, talk about data, talk to kids, and recruit people to be part of the STEM army, which means if you see a good science article, share it. Don't share a blog. Don't you dare share a blog. Okay, I'll talk to you about that later, but a credible source, please start credible sources only. Okay, I think it's time to show you how to actually do some stuff. Are you ready? Okay, now is this a group that wants to do demonstrations, or do they want to just sit there and watch me be crazy? Yes, that's me. Okay, cool. That's all I needed to know. So here's one of the first ones I like to do. I need to point out that I'm obviously in goggles, gloves, and a lab coat. I work for the University of Texas, so it's very important that I reiterate that you must be safe at all times. Okay, now that the boring part's over. What I have here are 2 beakers. And one of the first things I like to do is start with this demonstration, especially if I'm in an elementary school. This one works really well there. And so the first thing we do is we try to, if I can open my bag, we add some food coloring. So I've got blue, yellow, green, or red. What do we want, guys? Blue. It's always blue. It's always blue. You can vouch for that. I go through more blue food coloring than anything else. And of course, that's a hard one to buy in bulk because nobody wants blue cookies. I don't know why that is, though. Okay, so we go from a heterogeneous mixture to a homogeneous mixture just by swooshing. And then we're going to come over here and set up our other beaker. And so now if I had a kid here, I would obviously have them wear cryogenic gloves because it's not safe to grab dry ice. But we all know dry ice is solid carbon dioxide, and as long as you don't hold it for too long, you're not going to burn your hands. And so this is the very first demonstration I like to do, just to kind of get the conversation started. I pick this up and dump it in here. Ooh. Ah. Ooh. I know it's 8 a.m., but you can join me. Okay, here we go. And so what I love about this demonstration is right away it's going to evoke some kind of response. Either you're going to be like, it is too early for this, or you're like, whoa, what is happening there? And so what we see is the sublimation of carbon dioxide. It starts as a solid, turns into a gas. And this is a really easy way to start talking about a physical change. Now, if I'm talking to a high school student, I'm going to push them. What kind of physical change? Is it sublimation? Is it condensation? And then the really smart kids, I'm going to take it an extra level. What is the energy doing here? And it's clearly an endothermic process. So that dry ice needs to take the energy from somewhere and then go through the transition into the gas. Next one. So then you take it up a notch. So the first thing I want to ask is, what are these called? Do we know? Graduated cylinders. Tell me you all knew that. You all knew that. Yes, there we go. Nikki knew it. She was yelling from the back. Okay, so what I have here are graduated cylinders. I filled them up with our Austin tap water, which is naturally basic because it runs over limestone and absorbs our minerals. But I've spiked it with something called universal indicator. And the universal indicator is going to let us know if something's going on inside our reaction vessel. Now I'm going to add some dry ice. We're just going to kind of slowly watch that same physical change we saw before, where we see the sublimation, where our solid dry ice is going to turn slowly into gaseous carbon dioxide. And then we see the color change in the inside. So we went from the purple, which was basic, pH greater than 7, to the green, which is neutral, which is about pH of 7, to yellow at the end. Yay, I love this one. Isn't it awesome? Yes. Okay, so now this one is acidic, so it's a pH less than 7. So we went from purple to green to yellow. And so we actually saw a chemical change in addition to the physical change that's still happening. Did you like that one? Yes, I love these. Oh, thank you! Perfect. All right, so now we're going to take it up a notch. And I'm going to try to do this. The water here is like way more basic than I was expecting. I didn't even spike this one. For those of you who are familiar with phenolphthalein, this was straight up. I didn't spike it at all with any base. So I'm not sure if this is actually going to work, but I'm actually really excited to try it. So now what we did here in these last 2 is we added dry ice or carbon dioxide to our solution through dry ice. Now I'm going to try to add carbon dioxide using my breath. So we'll see if this works. Oh, it's working. Ooh, ah. So this one is called a Valentine's Wish, and it's a really fun one to do after that without telling them what you're doing. Like, why am I exhaling? Well, you exhale carbon dioxide. Now here's just a question. What % do you exhale for carbon dioxide? Anybody know? 4%. 4. It's a common misconception because we're taught that you just exhale carbon dioxide, right? I mean, we are literally teach you that in 5th grade. However, if that was the case, CPR wouldn't work, right? Remember that? There we go. Okay, good. That's just a pet peeve of mine. I had to throw it in there. All right, so that's a Valentine's wish. I always do that on Valentine's Day, and my goal is to pick 2 people out of my class that I think are into each other, and I make them do it at the same time. However, sorry, you guys don't volunteer. They know that's coming up. But 2 years ago, I actually invited someone who was married to someone else up, and so I don't really try to do that one anymore because that was an accident. Okay, moving on. So now I want to stay with the color changes and do something that I think is a little bit more fun, but I'm not going to use carbon dioxide and I'm not going to use dry ice. So this is something, well, I actually don't want to tell you what it is in case you know already. So this is the 4 molar hydrogen peroxide. Okay, we're going to add this slowly. All 3 of these solutions that I'm adding are clear and colorless. They basically look like water. Now this second solution has 2 things in it. It's potassium iodate and a little bit of sulfuric acid. Again, looks like water. And the third one has 3 things in it. Malonic acid, starch, and a little bit of manganese sulfate. Ooh, how did I do that? What? Oh my goodness, isn't that crazy? 3 things that look like water. We added them together and they turned to that really cool amber solution. And then all of a sudden, magically, somehow, oh come on, there we go. Come on! Thank you. So this is called the oscillating clock, or the Briggs-Rauscher reaction. And so what happens is it very slowly goes from the clear colors, and then it goes to the amber color, and then to the blue. Now, because of my last question, I feel like we have a variety of STEM backgrounds in here, so I'm just going to go with like a kind of a simple explanation for this one. But if you want to know more, please come talk to me afterwards. But basically what we said, there's 5 things in there, and that's going to pop off, Chris. Hold on. So there's 5 things in there. And so what happens is we basically have A plus B, which react to form C. As soon as C forms, D is sitting here in the flask, so like, whoa, 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 I like that. And so D reacts with C to form B. Well, B reacts with A to form C, which reacts with D to form B. And so we end up having 2 competing mechanisms that happen over and over, back to back. This lasts for about 10 minutes, and then we slowly form a purple color, and we release something that we don't want to breathe. So Chris is going to be watching this to quench it in about 3 minutes, okay? All right, so now, back to a cryogenic. This is not a cryogenic. This is a cryogenic. Got our liquid nitrogen. Oh, I love this stuff. Isn't it amazing? So liquid nitrogen is very cold. It's negative 194 Celsius or 77 Kelvin. Oh, that feels good. Okay, what's room temperature in Celsius? 25, yes, right there. Okay, so now what we're gonna do is take this beautiful octopus, and we're gonna see what happens. And so now usually I like to fill the head of this octopus with helium, but there were 2 rules today. No fire, no helium. So instead this is boring old air. It still works though. Okay, so for the sake of time, I'm gonna pull this out here. And so I'm gonna show you what I do with my students, which is an example of a physical change. So it started off as this beautiful, wonderful octopus. And then I put it into liquid nitrogen, where I can show them an example of Charles' law, where we see as the temperature goes down, the volume of the gas is going to go down. And then as I bring it out of the liquid nitrogen, as the temperature warms back up to room temperature here, we see that our volume comes right back up. Now the cool thing is, though, if this is filled with helium, as soon as I let go, it literally starts to fly away. So the kids are like, what's going on? So we're going to pretend. Fly. Wow, that was so cool, yay! But that's another example of a physical change. And then we can start talking about density, like why does the helium float? Or why would the air sink, right? We can have all these conversations together. And we're gonna do a number of different stations afterwards while I clean up. We have 4 things over here, so this is actually one of them, so I'm gonna allow you guys to play with smaller balloons and some liquid nitrogen. This is another one I have over there for you. And what I'm gonna do is use a beaker and 2% calcium chloride. This is one you guys can actually do at home. One of the things that I firmly believe in is doing demonstrations where at least one thing you can actually do at your house with your kids, with your sister, with your grandma, whatever, okay? 2% calcium chloride, 2% sodium alginate. If you buy these things on Amazon, make sure you get food grade so you can actually eat these. Now let me show you why. Let's do some blue, some orange, a little bit of this other one too. Oh, we're leaking. That's all right. The blue one's working perfectly. Look at that, guys. That's how you make gummy worms. Ooh. Who wants to eat it? No. You don't want to eat it. Sodium alginate comes from algae. It's extracted from brown seaweed, and so it doesn't really taste that great, but for me, it's more of the texture. It's that like gooey texture, and this is considered to be a gel. So when the two things come in, we have an ion exchange, so the sodium alginate then releases the sodium and grabs the calcium, and so you end up creating this really beautiful long polymer, which ends up being like a gel because it's a liquid trapped inside of a liquid. So have you ever had a gusher before? That's what it would taste like. So you bite down in it, and then that like nasty calcium chloride comes out. So for kids, I have the kids eat it all the time, and they love it, but for me, it's just like too gross. I cannot do that again, so I would not do that to you, kind lady. Now, here's the next one. This is where we're taking it up a notch, and I'm going to start talking about catalysis. So here, I have 35% hydrogen peroxide, H2O2, and I'm going to try to break it down with a catalyst. So this is called Genie in a bottle, and this catalyst is my manganese trioxide. Now, because we're almost in October, I want to pretend that this is a ghost, okay? Let's see. I don't want it to be too big, Susan. I'm like terrified of hitting your ceiling. Oh, we got this. Okay, we're going to just give it a second. It's going to go. So what we're slowly seeing is our catalyst is coming in there. Oh, there it goes. Yeah, I love this one. Look at that. Oh my God, I love it. Okay, yeah, let's give it up for this one. And so this one is called Genie in a bottle, and so what we have is hydrogen peroxide, H2O2, and we've decomposed it with our manganese trioxide. So if you can see, if you're in the front, you can actually see the water right here that is condensing on the inside of our vessel, and we just released oxygen gas. Now, if I had a big source of fuel near here, I could actually light that gas on fire, and we would have a big explosion. But again, no fire in the library. All right, so I'm going to move this one just because it's hot. And now can I have my volunteers jump up for no reason at all. I just want you to like put this tarp out. I think it's more aesthetically pleasing, I think, maybe. No reason. There we go, guys. Thank you. And why not just go ahead and set the other one up for me, please? Yeah. All right, so now, and then you don't want to be there. Yeah, there we go. Okay. So now, this right here is a bigger Erlenmeyer flask, and so we have two competing catalysts. So that last one was the manganese trioxide. This one is potassium iodide. Now, I personally love that last one, the one we just did. It's my favorite. I think it's just so cool. You can never, I don't know, I just think it's awesome. But all of my colleagues disagree with me because they think this one's better, but they're wrong. So we're going to vote, and you're going to have to tell me which one you think is better. So this is hydrogen peroxide. H2O2 again, 35%, same thing. I'm just using a little bit more of it. Need food calling. I also have Dawn dish soap here. There is no reason why we use Dawn dish soap, but they save penguins and they're my favorite animals, so we always support Dawn. And then we need some food coloring. We have blue, yellow, green, or red. What do we want, guys? Green. That's good. So green and blue. We're going to have some kind of really beautiful turquoisey type thing. That's good. And again, we're going to look for a heterogeneous mixture. Chris, can I have you get that for me, please? Ooh, that is beautiful. Good call on the green. I love that. You can use the same type of chemistry to make vomit out of a pumpkin. This would be good vomit. We got to remember that. Okay, so now, actually, can you move my doer out of here just again for no reason? Here we go. Potassium iodide into hydrogen peroxide. Let's see what happens here. Oh, beautiful. That's a good one. And I didn't hit your ceiling. That was the bad one last year, so give it up for Yay Elephant Toothpaste. Look at that. I love it. Science before 9 a.m., man. That's how you do it. I love this. Okay, this is Elephant's toothpaste, so we're releasing oxygen gas. We trapped it inside of the dish bubble, so it's going to continue to release and be trapped inside. Again, you could light this on fire if you had a good source of fuel sitting around here. Oh my gosh, look at that one. All right, y'all.
I want you to know security.
Hi. Hello. Turn around for the next one because it's grand finale time. So what we have here is I have a bucket over there in the green in just a second after Chris is done. Can we please give it up for my amazing volunteers who got here at 7 a.m. on a Friday? That's perfect, thank you. All right, so now what we've got here is our big bucket. Can you prep that for me? And what I'm going to do is add about 5 liters of liquid nitrogen-ish. Let's do 10. Okay, 5. And then what I'm gonna do is add a little bit of hot water. Now, when I'm in a safe space where there's not beautiful, well-dressed women right in front of me, just put that behind there just in case, okay? I usually do this, and I try to throw my hot water in so I can get about 3 stories high. Now, like I said before, not allowed in this building, so we're gonna do like a bunch of little baby ones. Are you good, Chris? Okay, here we go. Guys, thank you so much for coming out here. Please, please, please join my STEM army, share good science, talk to kids, and use evidence-based conversations. Here we go. 3, 2, 1. Yay! Where is it? Let's do it again. Oh, that one was cool. Thank you guys so much. Hook 'em home.